Hi all. I am going to present about electric overhead traveling crane, which is commonly referred as EOT crane. I have seen this in my industrial training. I have carried out my industrial training at Carriage and Wagon Works in Perambur. Let's get into it. These are also called as the bridge cranes. As the name suggests, it is operated by electric. It will be operated by an operator who is present there. He may be present inside a cabin or by using an pennant, which may be wired or wireless. Then these EOT cranes are basically used where lifting and lowering of heavy loads or heavy loads is required, which cannot be done by manually. These EOT cranes are basically used in railway workshops, manufacturing units, warehouses, where unloading and loading and relocating of heavy components or objects like bogie, bolster, and wheel set is required. Uh, when compared to older manual method, which it can be used efficiently and safely, and also much more in you know better in every aspect, like like in time consumption, safety, efficiency, and uh, amount of load it can carry is about vary from uh, 1 to 35 tons, which cannot be imagined by manually. Then it offers you greater degree of mobility and maneuverability. uh, then Based on the types of girder used, it can be this EOT can be classified into single girder and a double girder bridge canes. Basically, girder is also a type of beam, that is type of beam, but girder can be used to handle much more heavier loads and dynamic loads. So based on the number of girders used, it can EOT can be classified into two types. Then this is the pictorial representation of the double girder EOT crane. Um, this is known as the runways. This is a runway, and this is also a runway. So these are called as the parallel runways. Uh, on this parallel runways, it is an I-shaped cross-sectional beam, and on this parallel runway located the right runway rail, on which the end track, which is end track moves. On this end track, there will at the both ends of the end track, there will be an drive wheel, which will be driven by bridge drive. And on top of the end track, there will be two bridge girder will be present. And the trolley, which hosts the hoist, will be will be presented in the this two bridge girders. And there will be also an pendant which will be present along with it. This one shown in this picture is an wired type. There may be also wireless type also be present. Along with it, there will be control switches. This trolley can be moved in this direction, like along the bridge ways, in this lateral direction. And there will be also an limits which will be present, which will help the trolley to which will provide a anti collision structure, and helps the trolley from colliding with this bridge drive and other structures present here. There will be also gravity limit switch or control switch, which will be present, which prevents this hook from uh, colliding with this base of the bridge girdle. And this hook will move either it will be used for lifting and lowering of the load. This trolley can move lateral wise. This hook can move upward or downward. And this entire bridge girdle, along with bridge uh, bridge girdle, can be moved along with the end track, which consists of wheels present here. It can be driven by the bridge driver, which basically consists of motor. All these movements are made possible by motor. And then the electric input from motor will be given by the control panel unit, which will be present in the structure. And then this limit switch and control and limit switches will cannot be seen here. But if you go and look at the train so much close in physical mode, you can find it actually. Then so these are the specifications of the EOT crane. This maximum lifting capacity means how much load it can lift. It basically ranges from 1 to 40 ton. Imagine if this amount of load, if this much amount of load it should be relocated from one place to another by using by using human power, then it will be an enormous and impossible task. Then comes girder type. It's basically two girder, because two girder is used for hosting the trolley. Then travel speed. This travel speed is basically the wait a minute. This will be the parallel runways. This is the end track. No, this is the end track on which this the bridge girdle is mounted. These are the end tracks on both sides of the parallel runways. This end track will move about 10 to 15 meter per minute. That is the entire movement of the girdle along with the trolley and hoist. This is 10 to 15 meter per minute. Then span. The distance between these two parallel runways is known as the span. It is about it can be ranged from 1 to 30 meter. And the price of the crane will be about 25 lakh. Then the crane type is EOT crane, that is electrically overhead crane. Operation is it can be operated either by an operator who is located in cabin, and also by pendant, which will be driven by either wire or wirelessly. Then lifting speed, that is lifting speed. This is the lifting speed. The speed about the speed up to which this hook can lift is about 2.5 meter per minute. Power source is obviously electric from grid to the control panel. Then from control panel to the motor, which will be used for lifting applications and movement applications. Then material is mild steel, which is also very good in corrosion resistance. Then this type of VOT cranes you will be mostly find in heavy industries. So this is the usage is obviously industrial. Then maximum lifting height from floor, the maximum height the load can be lifted with before it collides with this thing is called, actually it doesn't collide, but this maximum height the load can be lifted is called as the maximum lifting height. For anti collision, for preventing collision, there will be limits which will be present here. Then country of origin. This machine is particularly made in India, which I have seen. Then these are the mechanisms which are used for movement of up and downward movement of the up and hook. This is the upward and downward movement of the hook. It is used for the longitudinal motion of the bridge along the end track along the parallel pathways. And this will be used for trolley lateral movement along the bridge girdle. Basically, in all these types, you will find a motor which will be driven by electrical input given electric input given by uh, control panel. And control panel is control panels yeah the electricity will be from grid to control panel. From control panel to limited amount of power electricity will be given to motor. And then from motor, it will be from motor, the shaft will be coupled to an speed reducer. Then the output shaft of the speed reducer will be connected to the will connect it to the coupling and to the reel, where it will provide either clockwise or anti-clockwise to lift or lower the load. Basically, this speed reduces will be an what I saw is an it will be based on gear train, where it will be used to lower the speed and increase the torque. And then it is also same from motor that is that from is also same from motor. There will be an coupling. From coupling to the shaft is coupled to an gear reducer input shaft. Then the speed is reduced and the torque is increased, and this will be coupled to the out. This will be coupled to the output wheel, which will be used for either running in an parallel parallel bridge girdle or parallel runways. So these are the mechanisms by which these electrical overhead crane is operating. And these are the three movements: crane hook up and down, which means this essentially this is for lifting and lowering of the load. And trolley lateral movement means the trolley which was the hoist is moving across the. So this is the parallel runway. This is the bridge girdle. So this is the trolley. Sorry, this is the trolley, and a trolley also hosts the hoist. This crane hook and up and down lifting will be represented by this, and trolley lateral movement will be like this. All are driven by motor, and this crane long traveling longitudinal motion will be like this. Basically these parallel runways are basically supported by uh, vertical columns, which will be presented in industry. uh, that's it. That comes to the end of the presentation. Thank you.